Right now, in the silence around you, something impossible is happening. Invisible particles are passing through your skin, through your eyes, through your heartbeat, through the walls around you, through the entire planet beneath your feet. Trillions of them move through your body every single second, and almost none of them will ever touch you. The universe is filled with ghosts, not spirits, not myths, but ancient particles born inside stars, exploding galaxies, and the first violent seconds after the birth of reality itself. They cross oceans of space without slowing down. They pass through suns as if suns were made of smoke. And at this very moment, countless neutrinos are flowing silently through your body while you remain completely unaware of their existence. If you watched our earlier journey into the strange darkness between galaxies, where invisible matter may shape the structure of the cosmos itself, then tonight's mystery connects beautifully to that question. Because once again, the universe is revealing that most of reality is hidden from human senses. Welcome to Velarin's Sleepy Space Mysteries. Tonight, we descend into one of the quietest mysteries in all of physics, the story of the neutrino, the particle so elusive that scientists once believed humanity would never detect it at all. Before we continue drifting deeper into the cosmos together, take a quiet moment to like the video, subscribe to the channel, turn on notifications, and if you wish to support these long journeys through the universe, you can also join the channel membership. And somewhere out there in the night, tell me softly in the comments, where in the world are you listening from tonight? To understand why neutrinos are so strange, we first need to understand something even stranger: matter itself. The chair beneath you feels solid. The walls around you feel solid. Your own body feels solid and permanent. But this solidity is mostly an illusion created by invisible forces. Inside every atom lies an enormous emptiness. If an atom were expanded to the size of a cathedral, its nucleus would be no larger than a grain of dust suspended at the center. Everything else would be empty space, vast silent emptiness held together by forces humans cannot see. And yet neutrinos ignore almost all of those forces. They slip through matter because the universe barely gives them any way to interact with anything at all. They carry no electric charge. They do not respond to the force that allows your hand to touch a table or your feet to rest upon the earth. They move through reality almost untouched, like whispers passing through stone. For decades, physicists struggled to understand them. Entire underground laboratories were built beneath mountains and ice sheets in desperate attempts to catch a single fleeting interaction. Deep below the Earth, scientists waited in darkness for particles born inside the sun itself. Tiny messengers carrying secrets from places no human could ever reach. And perhaps the strangest part of all is this: some of the neutrinos passing through your body tonight began their journey before Earth even existed, before the oceans formed, before the first stars of the Milky Way were born. Ancient particles from the beginning of time are still drifting silently across the universe, still crossing galaxies, still moving through you now. Tonight, we follow them into the deepest darkness of the cosmos. To truly understand why neutrinos drift through the universe like ghosts, we must begin with something that feels ordinary: the sensation of touch. At first, this seems simple. You place your hand against a table and the table pushes back. You lie down on a bed and the mattress supports your body. You walk across the ground and the earth holds you above its surface. These experiences feel immediate and unquestionable. Matter appears solid, stable, dense. But deep beneath human perception, reality behaves very differently. Inside every atom there is almost nothing at all. The nucleus at the center contains protons and neutrons packed together with incredible density. But the nucleus itself is unimaginably tiny compared to the atoms surrounding it. If an atom were expanded to the size of an enormous stadium, the nucleus would appear smaller than a marble resting quietly at the center field. The electrons would drift far away near the outer edges. And between them there would be emptiness. Silent emptiness stretching across almost the entire structure. This means your body is mostly empty space. The walls around you are mostly empty space. Mountains are mostly empty space. Even stars themselves are built from structures dominated by absence rather than substance. And yet the world does not feel empty. You cannot walk through a wall. Your hand does not pass through the table. Something prevents atoms from collapsing through one another. The answer is not solidity in the ordinary sense. It is force. Invisible fields reaching across microscopic distances. The electrons inside your body carry negative electric charge. The electrons inside the table also carry negative charge. Similar charges repel each other. As your hand approaches the table, electromagnetic fields begin pushing against one another long before any atomic nuclei could physically meet. What you experience as touch is actually the resistance created by electric fields. The entire physical world of texture and pressure and weight emerges from invisible interactions between charged particles. And this is where neutrinos become strange beyond imagination. Because neutrinos do not participate in this electromagnetic world at all. They carry no electric charge. None. The force that shapes nearly every human experience has absolutely no hold over them. Light cannot easily stop them. Magnets cannot deflect them. Matter cannot meaningfully resist them. They pass through the electromagnetic architecture of reality almost untouched. The universe itself is governed by four fundamental forces. Everything that has ever happened. Every star that has burned, every planet that has formed, every heartbeat in every living creature, all of it emerges from these four interactions. Gravity shapes galaxies and pulls worlds into orbit. Electromagnetism creates chemistry, light, and the sensation of touch. The strong nuclear force binds atomic nuclei together with enormous power. And finally, there is the weak nuclear force, the quietest and strangest of them all. The weak force does not build stable structures the way the other forces do. Instead, it transforms particles from one form into another. Deep inside radioactive atoms, the weak force allows neutrons to change into protons. It allows stars to fuse hydrogen into helium. And during these transformations, neutrinos are born. But the weak force carries a terrible limitation. Its range is extraordinarily small, smaller than almost anything humans can intuitively imagine. It reaches only across tiny fractions of atomic nuclei before fading away. This means that for a neutrino to interact with matter, it must pass unbelievably close to another particle. Not close in the everyday sense. Not even close in the atomic sense. It must almost directly strike the heart of a nucleus itself. And that almost never happens. Imagine firing a single grain of sand across an entire continent and hoping it collides perfectly with another grain of sand drifting through the air. That comparison still exaggerates how likely a neutrino interaction actually is. The probabilities are so absurdly tiny that trillions of neutrinos can pass through your body every second without leaving any trace whatsoever. At this moment, the Sun is producing unimaginable floods of neutrinos deep within its core. In the crushing pressure at the center of the star, hydrogen nuclei collide and fuse together in thermonuclear reactions. Energy is released, light is born, and neutrinos emerge as silent byproducts of stellar fusion. Every second, the Sun creates roughly 200 billion neutrinos. They surge outward through the dense solar interior at nearly the speed of light. And here the contrast becomes astonishing. A photon born inside the Sun does not travel freely. Light interacts electromagnetically with the dense plasma around it. It gets absorbed and emitted again and again. It scatters endlessly through the solar interior in a chaotic random walk. A single photon may require hundreds of thousands of years to finally escape the Sun's surface and travel into space. But the neutrino slips away almost immediately. It passes through the dense solar core as if the star barely exists. In roughly 2 seconds, it escapes the entire Sun. Then it races across 150 million kilometers of empty space and reaches Earth 8 minutes later. The light warming your skin today may have begun its journey before human civilization existed. But the neutrinos passing through your body tonight were born only moments ago inside the living furnace of the Sun. And they do not stop when they reach Earth. They continue downward through the atmosphere, through buildings, through oceans, through the rocky crust beneath your feet. Many pass directly through the entire planet itself and emerge silently into space on the opposite side. The Earth cannot stop them. Mountains cannot stop them. Entire planets are almost transparent to these ghost particles. The universe has created something so elusive that reality itself struggles to hold on to it. The deeper physicists studied neutrinos, the more unsettling they became. At first, the particles seemed almost invisible to reality itself. A ghost born from radioactive decay and nuclear fusion. A particle so indifferent to matter that many scientists believed it might remain forever beyond human reach. But beneath that mystery hid another question even stranger than invisibility. If neutrinos almost never interact with anything, how could humanity ever hope to detect them at all? To answer that question, scientists were forced to think on scales so enormous that ordinary intuition completely failed. A single neutrino passing through matter is extraordinarily unlikely to collide with anything. But the universe does not produce neutrinos one at a time. Produces them in floods beyond imagination. Every second, trillions upon trillions stream outward from stars, radioactive elements, exploding galaxies, and ancient cosmic events older than Earth itself. The challenge was not finding neutrinos. The challenge was persuading even one of them to leave behind the faintest whisper of evidence. During the early 20th century, physicists studying radioactive decay discovered something disturbing. Certain atomic nuclei emitted electrons with strange energies that seemed to violate the law of energy conservation. The numbers refused to balance correctly. Some energy appeared to vanish during the decay process itself. This terrified physicists because conservation of energy was not merely another scientific theory. It was one of the deepest foundations of all modern physics. If energy could truly disappear, then much of science would collapse with it. In 1930, the Austrian physicist Wolfgang Pauli proposed a desperate solution. He suggested that an invisible particle was escaping unnoticed during radioactive decay and carrying away the missing energy. This hypothetical particle had to be electrically neutral. It had to possess almost no mass, and it had to interact so weakly with matter that no instrument on Earth had yet observed it. Pauli himself worried the idea might sound absurd. He reportedly apologized to his colleagues for inventing a particle that could probably never be detected. That invisible particle would later become known as the neutrino. For decades it remained only a theory, an elegant mathematical ghost protecting the laws of physics from collapse. Scientists searched for ways to catch it, but the probabilities seemed hopelessly small. Neutrinos passed through detectors without leaving traces. They ignored ordinary matter almost completely. Even enormous walls of lead barely slowed them down. Then humanity entered the nuclear age. Nuclear reactors transformed the problem entirely. Inside reactor cores, unstable atomic fragments underwent continuous radioactive decay, producing unimaginable torrents of neutrinos every second. Suddenly, physicists possessed a source intense enough that even incredibly rare interactions might eventually become visible. The universe had provided the flood. Humans only needed patience large enough to wait for a single drop to strike. In the 1950s, physicists Frederick Raynes and Clyde Cowan built one of the first successful neutrino detection experiments near a nuclear reactor in South Carolina. Their detector relied on enormous tanks of liquid carefully monitored for tiny flashes of radiation. On extraordinarily rare occasions, a neutrino passing through the detector would collide with a proton inside an atom. The collision would create new particles and brief bursts of light. These faint flashes lasted only moments before vanishing again into darkness. Most neutrinos still passed through untouched. Countless trillions crossed the detector every second without interacting at all. But eventually, after enough waiting, a few collisions appeared. Tiny signatures hidden inside oceans of silence. The impossible particle had finally revealed itself. Imagine the emotional weight of that moment. For decades, neutrinos had existed only as mathematical necessities, invisible solutions to broken equations. Now humanity had directly observed one of the strangest objects in the cosmos. A particle capable of crossing stars and planets almost without resistance. A messenger from the hidden nuclear engines of reality itself. And yet detection remained extraordinarily difficult. The world above ground was filled with noise. Cosmic rays from space constantly bombarded Earth's atmosphere, creating showers of energetic particles that flooded detectors with false signals. To escape this interference, scientists moved their experiments underground, deep beneath mountains, beneath mines, beneath kilometers of rock. The Earth itself became a shield. Far underground, cosmic radiation faded into silence. Only neutrinos retained the power to penetrate such depths easily. In these quiet chambers, physicists built strange hidden observatories unlike anything humanity had ever imagined. Gigantic tanks of purified water, vast pools of chemical fluids, caverns lined with delicate light sensors watching endlessly for microscopic flashes in darkness. One of the most famous experiments emerged inside the Homestake gold mine in South Dakota. Nearly 1.5 kilometers underground, physicist Raymond Davis Jr. filled a massive tank with hundreds of tons of dry cleaning fluid. It sounded almost ridiculous. A cosmic observatory built from industrial solvent buried deep inside a mine. Yet the logic was brilliant. Very rarely, a neutrino from the sun would collide with a chlorine atom inside the fluid and transform it into argon. Davis searched patiently for these newly created argon atoms. The difficulty was almost unimaginable. Across hundreds of tons of liquid, he might detect only a few atoms over many weeks. A handful of microscopic traces hidden inside an ocean of chemicals. And still he waited. Year after year Davis repeated the process, extracting atoms one by one from darkness beneath the earth, listening for whispers from the sun itself. It was among the most patient scientific experiments ever attempted. A human being dedicating decades of life to particles that barely acknowledged existence. Then another mystery appeared. The sun seemed to be producing too few neutrinos. Again and again, the detector observed fewer neutrinos than theoretical models predicted. Something was wrong. Either humanity misunderstood the inner workings of stars, or neutrinos themselves possessed hidden behaviors no one yet understood. The ghost particle had solved one crisis in physics only to create another. And somewhere inside that mystery lay a discovery that would eventually reshape modern physics forever. For more than 30 years, the solar neutrino mystery remained unresolved. Deep underground, Raymond Davis continued counting impossibly rare interactions inside his silent tank beneath the earth. Again and again, the numbers arrived with the same unsettling message. The sun appeared to be missing neutrinos. Not a few. Nearly 2/3 of them seemed to vanish somewhere between the solar core and Earth itself. The implications were enormous. If the measurements were correct, then perhaps physicists misunderstood how stars produced energy. That possibility alone was deeply disturbing because stellar physics had become one of the most successful achievements of modern science. The equations describing fusion inside stars explained the sun's brightness, its temperature, its lifespan, and the behavior of countless stars scattered across the galaxy. To discover that these models were fundamentally wrong would shake astrophysics to its core. But there was another possibility, one far stranger. Perhaps the neutrinos themselves were changing during their journey through space. At first, this idea sounded almost impossible. Physicists had long assumed neutrinos were massless particles traveling forever unchanged at the speed of light. But quantum mechanics allows reality to behave in ways that defy ordinary human intuition. Deep within the mathematics of particle physics emerged a strange prediction. If neutrinos possessed even the tiniest amount of mass, they might oscillate between different identities as they traveled. The universe actually contains 3 known types of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. They are often called flavors. The sun primarily creates electron neutrinos during nuclear fusion. Raymond Davis's detector could only observe that specific flavor. If neutrinos changed into different forms while crossing space, then many arriving at Earth would become invisible to his experiment. The missing neutrinos might not be missing at all. They might simply be wearing different masks. To test this idea, Scientists needed detectors far larger and more sensitive than anything built before. In Japan, beneath Mount Aikino, physicists constructed one of the most extraordinary scientific instruments in history, Super Kamiokande, a gigantic underground chamber filled with 50,000 tons of ultra-purified water. The detector rested deep inside a mine beneath layers of rock shielding it from cosmic radiation. Along the walls surrounding the water stood thousands of enormous light sensors waiting silently in darkness. The purpose of the detector was both simple and profound. Wait for a neutrino to strike. When a neutrino occasionally collided with an atomic nucleus inside the water, the interaction could create a charged particle moving faster than light travels through water itself. This did not violate relativity because light slows down inside transparent materials. The resulting particle produced a faint blue flash known as Cherenkov radiation, a delicate ripple of light spreading through darkness like a whisper across still water. Most days only a handful of neutrinos interacted at all. Yet over time patterns began to emerge. The detector studied neutrinos created high above Earth's atmosphere when cosmic rays from deep space slammed into air molecules. Some of these atmospheric neutrinos traveled downward into the detector after crossing only a short distance through the atmosphere. Others were produced on the opposite side of the planet and passed directly through the entire Earth before reaching Japan from below. If neutrinos never changed flavor, both groups should arrive in roughly equal numbers. But they did not. The neutrinos that traveled longer distances through Earth appeared to vanish far more often. The farther they traveled, the more disappeared. The conclusion slowly became unavoidable. During their journey through space and matter, neutrinos were transforming into other flavors invisible to the detector. The ghost particle was changing identity while in motion. In 1998, the evidence became overwhelming. Neutrino oscillation was real, and with it came a revolutionary discovery. Neutrinos must possess mass after all. Not much mass. In fact, their masses are so tiny that scientists still struggle to measure them directly even today. But the discovery shattered an important assumption within the standard model of particle physics. One of humanity's greatest scientific theories had quietly contained an error for decades. The neutrino once again forced physics to evolve. And still the mystery deepened further. Another extraordinary observatory soon appeared deep underground in Canada. The Sudbury Neutrino Observatory, often called SNO, used 1,000 tons of heavy water contained within a transparent sphere surrounded by thousands of sensitive light detectors. Unlike earlier experiments, this detector possessed a remarkable ability. It could observe all three neutrino flavors instead of only one. Finally, humanity had a way to test the solar neutrino mystery directly. The results arrived with breathtaking clarity. The Sun was producing exactly the expected number of neutrinos all along. None were missing. During their 8-minute journey from the Sun to Earth, many electron neutrinos simply transformed into muon and tau neutrinos before arriving. Raymond Davis had not failed to detect them because his experiment was flawed. He failed because the particles themselves had changed shape during flight. For decades, the universe had been quietly misleading humanity through a quantum illusion. The realization carried a strange beauty. Neutrinos were not static objects drifting unchanged through space. They existed in shifting quantum states, fluid identities oscillating invisibly across cosmic distances. A neutrino born in the Sun could arrive at Earth as something fundamentally different from what it had been at birth. And this transformation revealed something profound about reality itself. At the smallest scales, particles are not simple solid objects. They behave like waves of probability. Their identities blur and evolve according to hidden quantum rhythms impossible to perceive in ordinary life. Neutrinos became living evidence that the universe is far stranger and more fluid than human intuition ever imagined. Yet even after these discoveries, neutrinos continued slipping through reality almost untouched. Trillions still pass through every human body every second. Through mountains, through oceans, through planets. The detectors humanity built were monumental triumphs of patience and engineering, but compared to the true flood of neutrinos surrounding Earth, they captured only microscopic traces. The vast majority continue their endless journey unnoticed, ghosts crossing the cosmos in silence. And some of them are older than the stars themselves. Among all the particles humanity has discovered, neutrinos may be the closest thing nature has created to pure invisibility. And yet, despite their ghost-like behavior, they are everywhere. The universe is saturated with them. Every star produces them. Every supernova unleashes unimaginable storms of them. Radioactive elements hidden beneath Earth's crust quietly release them into the darkness below our feet. Even the atmosphere above your head glows with invisible neutrino rain created when cosmic rays collide with molecules high in the sky. And perhaps most astonishing of all, the universe itself still carries ancient neutrinos left behind from the beginning of time. To understand this final mystery, we must travel backward farther than human imagination comfortably allows. Back before planets existed, before galaxies formed, before stars ignited across the darkness. We return to the first second after the birth of the cosmos itself. In those earliest moments, the universe was not filled with stable matter. It was a violent ocean of energy and particles compressed into unimaginable density and heat. Temperatures exceeded billions of degrees. Space itself was smaller than an atom. Matter and radiation collided constantly in a blinding storm where particles appeared and vanished endlessly. Inside this primordial chaos, neutrinos interacted freely with everything around them. They collided with electrons, protons, and radiation in rapid succession. The young universe was so dense that even neutrinos could not travel far without striking something. For a brief time, the ghost particles were trapped within the cosmic fireball alongside everything else. But the universe was expanding. As space stretched outward, temperatures slowly fell. Matter spread apart, and eventually, roughly 1 second after the Big Bang, conditions changed forever. The cosmos became thin enough that neutrinos could finally escape without constant collisions. They decoupled from the rest of matter and began drifting freely through expanding space. They have never stopped. For more than 13 billion years, these primordial neutrinos have crossed the universe in silence. Older than galaxies, older than stars, older than Earth itself. Ancient travelers from the birth of reality still moving through space at this very moment. Right now, countless relic neutrinos from the first second of the universe are flowing through your body. You cannot feel them. No human sense can detect them. Yet they are among the oldest surviving particles in existence. Silent witnesses to the birth of the cosmos itself. This idea changes something deep inside human perspective. The atoms within your body were forged later inside stars. The oxygen you breathe, the carbon in your cells, the iron in your blood, all of it emerged billions of years after the Big Bang through stellar fusion and supernova explosions. But some neutrinos surrounding you tonight began their journey before any star had ever existed at all. They are fossils from the dawn of time, and still neutrinos continue revealing new secrets. In Antarctica, buried deep beneath the frozen South Pole, scientists constructed one of the largest detectors ever created, Ice Cube. Instead of using tanks of water or chemical fluids, physicists transformed an entire cubic kilometer of ancient Antarctic ice into a neutrino observatory. Thousands of light sensors were lowered deep into the ice sheet where the frozen darkness remained perfectly clear and silent. The purpose of Ice Cube was extraordinary. Detect neutrinos arriving not from the Sun or Earth, but from the most violent regions in the universe itself. Sometimes, far beyond the Milky Way, gigantic black holes feed upon surrounding matter. As gas spirals inward, enormous jets of particles blast outward across intergalactic space at nearly the speed of light. Somewhere within those violent cosmic engines, neutrinos are born with energies millions of times greater than anything produced by ordinary stars. Most still pass unnoticed through the universe forever. But once in a great while, one strikes the Antarctic ice. A tiny flash appears beneath the frozen continent. A ripple of blue light spreading through darkness. From that fragile signal, scientists reconstruct the trajectory of a particle that traveled billions of light years across the cosmos before finally touching Earth. Humanity has begun using neutrinos as astronomical messengers. Unlike light, neutrinos can escape from environments so dense that photons become trapped. They emerge from exploding stars before visible light escapes. They cross directly through regions hidden behind clouds of dust and radiation. They carry information from places the electromagnetic universe cannot fully reveal. In a sense, neutrinos allow humanity to look through walls the cosmos once kept sealed. And still many mysteries remain unsolved. Scientists do not yet know the exact masses of neutrinos. They do not fully understand why the particles possess such tiny masses at all. Some physicists suspect neutrinos may hold clues to one of the greatest mysteries in existence. Why matter survived after the Big Bang instead of annihilating completely into radiation. Why stars, planets, oceans, and living creatures exist at all instead of endless emptiness. The ghost particle may help explain why reality itself survived. And there is something strangely peaceful about all of this. As you sit quietly listening tonight, invisible rivers of neutrinos continue flowing endlessly through the universe. Through your room, through the earth, through oceans and mountains and sleeping cities beneath the night sky. Ancient particles from the hearts of stars and the birth of time itself passing silently onward without pause. The universe is far less solid than it appears. Beneath the familiar world lies an invisible ocean of ghost particles drifting through eternity. And almost none of them will ever know we were here. On February 23, 1987, the universe whispered to Earth. Far beyond the Milky Way, inside a small companion galaxy known as the Large Magellanic Cloud, a massive blue supergiant star reached the end of its life. For millions of years, the star had balanced gravity against nuclear fusion. Deep within its core, hydrogen became helium. Helium became carbon. Carbon became heavier elements in an endless chain of stellar burning. Layer upon layer of fusion unfolded like a slow cosmic heartbeat inside the dying giant. But eventually the process reached iron, and iron changes everything. Unlike lighter elements, iron cannot release energy through fusion. Once a star's core fills with iron, the furnace sustaining it begins to fail. Gravity, which had waited patiently for millions of years, finally gains the upper hand. The star can no longer support its own unimaginable weight. In less than a second, the core collapses. Matter falls inward at terrifying speed. Temperatures explode upward into impossible extremes. Electrons and protons crush together to form neutrons. The core shrinks from thousands of kilometers across to a sphere barely larger than a city. The collapse becomes so violent that the outer layers of the star rebound outward in a colossal explosion. A supernova is born. For a brief moment, this single dying star can outshine entire galaxies. But the visible explosion is not the true story. Most of the energy released during a supernova does not emerge as light. Almost all of it escapes as neutrinos. During the collapse, conditions inside the star become so dense and energetic that unimaginable floods of neutrinos erupt outward from the dying core. In only a few seconds, the collapsing star releases more neutrinos than our Sun will produce across its entire 10 billion-year lifetime. A storm of ghost particles races into space, carrying away nearly all the energy of the explosion. And in 1987, some of those neutrinos reached Earth. What makes this moment extraordinary is timing. Neutrinos escape from a collapsing star almost immediately because they interact so weakly with matter. Light cannot escape so easily. The outer layers of the exploding star remain dense and opaque, trapping photons for hours before visible radiation finally breaks free into space. This means the neutrinos arrived first, before telescopes saw the supernova. Before astronomers even knew a star had exploded. Tiny underground detectors quietly recorded faint neutrino interactions deep beneath Earth's surface. In Japan, inside the Kamiokande detector buried beneath Mount Aikino, scientists observed a sudden burst of mysterious events. In the United States, another detector buried beneath Lake Erie also registered unusual signals. Altogether, only a few dozen neutrinos were detected, just a tiny handful out of the unimaginable flood passing through Earth. But that handful changed astronomy forever. For the first time in human history, humanity directly observed neutrinos from an exploding star. Think about the scale of what happened. These particles traveled for roughly 168,000 years across intergalactic space. They crossed darkness older than human civilization itself. They passed through magnetic fields, gas clouds, stars, and entire planetary systems. Then, after their endless journey, a few finally touched detectors hidden deep beneath Earth. A dying star in another galaxy had whispered directly to humanity through neutrinos, and the message arrived before the light itself. This revealed something profound about neutrinos. They are not merely strange particles drifting invisibly through space. They are messengers capable of carrying information out of places light cannot easily escape. Photons interact constantly with matter and radiation. They scatter, absorb, and become trapped. But neutrinos pass almost untouched through environments so dense that ordinary light cannot survive. In a sense, Neutrinos allow humanity to peer directly into the hidden interiors of cosmic catastrophes. Today, physicists believe neutrinos could help us study some of the most violent events in existence. Colliding neutron stars, black hole jets, the collapse of giant stars, perhaps even processes occurring near the edge of black holes themselves. The ghost particle may eventually become one of humanity's most powerful tools for understanding the hidden universe. And yet, neutrinos remain frustratingly elusive. Even enormous detectors capture only microscopic traces. Imagine standing in the middle of a hurricane and trying to collect individual raindrops using a single blade of grass. That comparison still exaggerates how easy neutrino detection actually is. Entire underground lakes of purified water may observe only a handful of interactions each day despite trillions upon trillions of neutrinos passing through them constantly. To improve their chances, scientists began constructing detectors on scales once thought impossible. In Antarctica, physicists transformed the frozen continent itself into a scientific instrument. Deep beneath the South Pole lies Ice Cube, a detector stretching through 1 cubic kilometer of ancient ice. Thousands of optical sensors remain suspended in darkness far below the surface where the ice becomes astonishingly clear. The frozen landscape above appears silent and empty, but below, invisible cosmic particles move endlessly through the Earth. Occasionally, a high-energy neutrino collides with an atom inside the ice. The interaction creates a fast-moving particle that produces faint blue Cherenkov light spreading outward through the frozen darkness. Sensitive detectors capture these brief flashes and reconstruct the neutrino's path backward across the cosmos. In this way, Antarctica has become an observatory for invisible astronomy. And the discoveries have already become extraordinary. Some neutrinos detected by Ice Cube carry energies millions of times greater than those produced inside the Sun. These particles likely originate from environments of unimaginable violence near supermassive black holes and gigantic relativistic jets blasting across intergalactic space. The universe is not silent. It is alive with invisible storms humanity only recently learned how to hear. Yet every new answer creates another mystery. Because neutrinos continue behaving unlike anything else in physics. They possess tiny masses no theory fully explains. They oscillate between identities while crossing space. They ignore most of reality while somehow preserving information from the birth and death of stars. And somewhere within those mysteries may hide answers to questions even deeper than the origin of neutrinos themselves. Questions about why the universe exists at all. There is a strange paradox at the heart of neutrinos. The universe produces them in unimaginable abundance, yet they remain among the most difficult objects humanity has ever tried to study. They are everywhere and almost nowhere at the same time, passing endlessly through every living creature, through every ocean, through every planet, through entire galaxies, and still remaining nearly invisible to reality itself. This paradox forced physicists into an unusual relationship with patience. Most sciences allow direct observation. A chemist mixes substances and watches reactions unfold. An astronomer points a telescope toward the sky and captures light immediately. But neutrino physics often means waiting silently underground for months or years, hoping for only a handful of interactions. Entire careers can pass between major discoveries. And perhaps that slowness feels strangely appropriate for a particle born from the deepest hidden layers of the universe. The detectors themselves have become almost cathedral-like in their scale and atmosphere. Deep underground chambers filled with purified water glowing faintly in darkness. Silent caverns carved beneath mountains where scientists listen for invisible particles crossing the Earth from distant stars. There is something almost spiritual about these observatories. Human beings descending beneath the surface of the planet not to escape the cosmos, but to hear it more clearly. Because the Earth above acts as a shield. On the surface, cosmic rays constantly bombard the atmosphere. High-energy particles from space crash into air molecules and create enormous cascades of secondary radiation. If neutrino detectors operated openly beneath the sky, these signals would overwhelm everything. The delicate whispers of neutrinos would drown beneath cosmic noise. So physicists hide their instruments underground where rock absorbs most interfering radiation. And still the neutrinos pass through effortlessly. This creates one of the strangest images in modern science. Mountains powerful enough to stop energetic particles become meaningless to neutrinos. Entire planets barely slow them at all. The Earth itself acts not as protection against neutrinos, but merely as protection from everything else. In some experiments, physicists even use the entire planet as part of the detector design. A neutrino arriving upward through Earth has already crossed thousands of kilometers of solid rock and metal before reaching the observatory. If such a particle still arrives intact, scientists know it almost certainly must be a neutrino because nearly nothing else could survive that journey. The planet becomes a filter for ghosts. And yet, despite all these extraordinary methods, neutrinos still refuse to surrender their deepest secrets easily. One mystery in particular continues haunting modern physics. Why are neutrino masses so incredibly small? Every known particle possessing mass interacts with something called the Higgs field. This invisible field permeates the universe and gives particles resistance to motion, which humans perceive as mass. Electrons gain mass through interactions with the Higgs field. Quarks gain mass this way as well. But neutrinos behave differently. Their masses are absurdly tiny compared to all other known matter particles. Scientists still do not fully understand why. Some theories suggest neutrinos may interact with hidden physics beyond the standard model. Others propose entirely new particles or forces not yet discovered. There are even ideas suggesting neutrinos could help explain one of the greatest mysteries in cosmology itself. Why the universe contains matter at all. This question sounds simple at first, but it hides a profound problem. According to modern physics, the Big Bang should have created matter and antimatter in nearly equal amounts. Antimatter behaves almost identically to ordinary matter except with opposite electric charge. When matter and antimatter meet, they annihilate each other into pure energy. If equal amounts formed in the early universe, they should have destroyed one another almost completely. Stars would never have formed. Galaxies would not exist. Planets and oceans and living creatures would never emerge. The cosmos should contain little more than radiation spreading endlessly through darkness. And yet matter survived. Some tiny imbalance favored matter over antimatter in the early universe. Something shifted the cosmic scales slightly enough for ordinary matter to remain after the Great Annihilation ended. Everything humans have ever known depends on that imbalance. Physicists suspect neutrinos may somehow hold the answer. Certain theories propose that ancient neutrinos and their antimatter counterparts behaved slightly differently during the universe's earliest moments. Perhaps tiny asymmetries in their behavior created the imbalance that allowed matter to survive. If true, then neutrinos may be connected not merely to particle physics, but to the existence of stars, planets, and life itself. The ghost particle may help explain why reality did not disappear. Experiments searching for these answers continue around the world. New detectors are being constructed with astonishing ambition. Deep underground neutrino experiment, often called DUNE, is currently under development in the United States. Massive detectors buried beneath South Dakota will study neutrino beams traveling hundreds of kilometers through Earth from particle accelerators near Chicago. Scientists hope these experiments may reveal whether neutrinos and antineutrinos behave differently enough to explain the survival of matter after the Big Bang. Imagine that possibility for a moment. Tiny particles so elusive that trillions pass unnoticed through your body every second may ultimately explain why your body exists at all. And still there is another layer of mystery waiting beneath everything else. Some physicists wonder whether neutrinos might be their own antiparticles. Most particles possess distinct antimatter partners with opposite properties. But neutrinos may blur even this boundary. If true, matter and antimatter become strangely entangled within the neutrino itself. Experiments searching for evidence of this possibility involve enormous underground detectors waiting for incredibly rare radioactive processes that may occur only once across timescales longer than the age of the universe. Again, humanity waits patiently in darkness, listening for whispers almost too faint to exist. There is something deeply humbling about all of this. Human civilization often imagines itself surrounded by solid certainty, stable matter, predictable reality, familiar physical laws. But neutrinos reveal a very different cosmos hidden beneath ordinary perception. A universe filled with invisible particles slipping endlessly through space and matter. Ancient messengers carrying secrets from exploding stars and the birth of time itself. And perhaps the strangest realization is this. The universe may not be built primarily from the things we can see. Much of reality moves silently through us unnoticed. Ghosts crossing eternity beneath the surface of the visible world. If neutrinos teach humanity anything, it may be this. The universe is far quieter than it appears. Human beings evolved to notice light, sound, pressure, heat, movement. We experience reality through interactions strong enough to touch our senses directly. But neutrinos belong to a hidden layer of existence moving almost completely outside ordinary perception. They pass through the visible universe like silent currents flowing beneath the surface of an ocean. And the more physicists study them, the more the universe begins to feel less like solid machinery and more like a vast field of invisible probabilities. Quantum mechanics already revealed that particles do not behave like tiny billiard balls. Electrons exist as clouds of possibility until measured. Light behaves both like waves and particles simultaneously. But neutrinos push this strangeness even further. They blur identity itself. An electron neutrino leaving the sun is not entirely an electron neutrino anymore by the time it reaches Earth. During flight, it becomes a shifting mixture of possibilities oscillating between flavors according to hidden quantum rhythms. It is as though the particle cannot fully decide what it is while crossing space. This idea feels deeply unnatural to human intuition because people experience identity as stable. A mountain remains a mountain. Water remains water. But at the smallest scales of reality, nature behaves more fluidly. Particles drift between states. Probabilities interfere and overlap. Matter itself becomes less certain. And neutrinos embody this uncertainty more clearly than almost anything else known to science. There is another reason neutrinos fascinate physicists so deeply. Unlike most particles, they carry information across unimaginable distances almost untouched. Light can be blocked by dust clouds. Charged particles become bent by magnetic fields. Even gravitational waves distort and weaken as they spread through space. But neutrinos pass almost undisturbed through environments that would trap or destroy other messengers. This gives them extraordinary scientific value. Imagine trying to understand the interior of a star using only sunlight. The photons reaching Earth emerged from the sun's surface after countless collisions during journeys lasting hundreds of thousands of years. They tell us almost nothing directly about the core itself in real time. But neutrinos escape the solar interior nearly immediately after formation. When scientists detect solar neutrinos on Earth, they are effectively observing nuclear fusion occurring inside the sun only minutes earlier. Humanity is watching the stellar furnace live. And neutrinos may eventually reveal even deeper hidden structures inside the cosmos. Some scientists hope neutrino astronomy could help map violent regions surrounding black holes where ordinary light cannot easily escape. Others believe neutrinos may uncover unknown astrophysical phenomena never before imagined. Already the discoveries are becoming extraordinary. In 2017, the IceCube detector beneath Antarctica identified a neutrino carrying enormous energy from deep space. Scientists traced its path backward across billions of light-years to a distant blazar, a gigantic galaxy powered by a supermassive black hole launching jets of matter outward near the speed of light. For the first time, humanity identified a specific cosmic object producing high-energy neutrinos. A particle crossed the universe for billions of years before ending its journey beneath Antarctic ice. And from one tiny flash of blue light, humanity reconstructed the location of a violent galaxy unimaginably far away. This is what makes neutrino astronomy so beautiful. It transforms invisible particles into cosmic storytellers, messengers from places light alone cannot fully describe. Yet even now, neutrinos continue protecting their deepest mysteries carefully. One unresolved question concerns the exact ordering of neutrino masses. Scientists know neutrinos possess mass because oscillations prove it. But they still do not know which neutrino flavor is heaviest or lightest. The differences are astonishingly small, so small that measuring them pushes technology and mathematics to extraordinary extremes. Another mystery involves the total number of neutrino types existing in nature. So far, humanity knows 3 flavors connected to the electron, muon, and tau particles. But some experimental hints suggest the possibility of additional hidden neutrinos called sterile neutrinos. These hypothetical particles would interact even more weakly than ordinary neutrinos, perhaps only through gravity itself. If sterile neutrinos exist, they could reshape cosmology completely. Some theories even connect them to dark matter, the invisible substance believed to dominate much of the universe's mass. Once again, neutrinos drift toward the edges of humanity's deepest mysteries. Dark matter. the survival of matter after the Big Bang, hidden physics beyond the standard model. Everywhere scientists encounter uncertainty, neutrinos seem to linger nearby like shadows at the edge of understanding. And perhaps this should not surprise us. After all, neutrinos emerged from the earliest moments of the cosmos. They witnessed the first second of existence itself. They flow from exploding stars and collapsing stellar cores. They move through environments too violent for ordinary matter to survive unchanged. Maybe it is natural that they carry clues about the deepest architecture of reality. There is also something emotionally haunting about neutrinos. At this moment, particles from ancient supernovas are passing through your body. Neutrinos born when distant stars died long before human civilization existed continue crossing the universe tonight. Some originated in galaxies so remote that their light has not yet reached Earth. Others began their journey near the birth of time itself. The universe remembers its past through these particles, and those memories move silently through you now. Human beings often imagine themselves isolated from the cosmos, separate from stars and galaxies. But neutrinos reveal a universe profoundly interconnected. Every second your body becomes part of an invisible river flowing between stars, galaxies, and ancient cosmic events stretching across billions of years. You are not standing apart from the universe. You are immersed inside it completely. Invisible particles from the sun cross your skin every moment. Ancient relic neutrinos from the Big Bang drift through your heartbeat. Ghost messengers from dead stars move quietly through the earth beneath sleeping cities and dark oceans. The cosmos is not distant. It is flowing through you constantly. And perhaps the strangest truth of all is that almost none of this hidden universe was known to humanity only a century ago. The ghost particles existed all along, crossing stars and planets in silence while human civilization remained completely unaware. Reality was always stranger than it looked. We simply lacked the senses to notice. As the 20th century came to an end, neutrinos had already transformed physics. They solved the mystery of missing solar particles. They revealed that the standard model was incomplete. They opened entirely new forms of astronomy. And yet the deeper humanity looked into the ghost particle, the more reality itself seemed to dissolve into unanswered questions. Perhaps the strangest realization was this. Neutrinos are incredibly small contributors to the visible world humans experience every day, yet they may have played a decisive role in shaping the entire cosmos. In the early universe, moments after the Big Bang, matter and antimatter existed together inside a sea of unimaginable heat and density. According to known physics, they should have annihilated one another almost perfectly. Particle meeting antiparticle, matter collapsing into pure radiation, a brilliant flash followed by emptiness. And yet that did not happen. Somehow, a tiny imbalance emerged. For roughly every billion antimatter particles, there were about 1,000,000,001 matter particles. The difference sounds insignificant, almost microscopic. But after the Great Annihilation ended, that tiny surplus remained behind. From that surviving fraction came every galaxy, every star, every planet, every ocean, and every living creature that would ever exist. Everything humans know emerged from a slight asymmetry in the early universe. The question is why? Why did matter survive at all? This mystery sits at the center of modern cosmology, and neutrinos may hold the answer. Some physicists believe neutrinos behaved differently from antineutrinos during the universe's earliest moments. Tiny violations of symmetry may have slowly tipped the balance toward matter. If true, the ghost particles crossing your body tonight are connected to one of the greatest turning points in cosmic history. Without them, stars may never have formed. Life may never have emerged. The universe might contain nothing but radiation drifting through endless darkness. In a strange way, your existence may depend upon the subtle imperfections of invisible particles. And there is something poetic about that. Human beings often imagine the cosmos as cold and mechanical. But modern physics reveals a universe balanced upon astonishing fragility. Tiny fluctuations shaped galaxies. Quantum uncertainties influenced cosmic evolution. Invisible particles drifting almost unnoticed may have determined whether reality became populated with stars or remained empty forever. The deeper science descends into the foundations of existence, the more delicate everything begins to appear. Neutrinos also challenge humanity's understanding of permanence itself. Throughout this journey, we have returned again and again to the idea that matter feels solid only because of invisible forces. But neutrinos move almost freely through those forces. Entire planets become transparent to them. Mountains cannot meaningfully resist them. Even stars struggle to hold them back. This means the visible universe is not as closed or solid as human senses suggest. Reality is porous. Invisible rivers move constantly through every object humans perceive as stable. The Earth is not isolated from the cosmos. It is immersed within it. Every second, particles from distant stars pass through oceans, forests, sleeping animals, crowded cities, and human hearts without interruption. The boundary between Earth and the wider universe is far thinner than it appears. And perhaps that realization changes how we think about ourselves. Ancient humans once imagined the heavens as distant realms separated from ordinary life. But modern science reveals continuity instead. The atoms inside your body were forged inside stars. The calcium in your bones emerged from ancient supernovas. The oxygen filling your lungs was once part of stellar furnaces burning billions of years ago. And now neutrinos add another layer to that connection. Particles from the beginning of time itself move through you continuously. Ghost messengers from exploding stars cross your body silently every moment. The cosmos is not merely surrounding you. It is flowing through you endlessly. There is also a strange comfort hidden inside the neutrino story. These particles are astonishingly difficult to stop. They cross galaxies almost untouched. They survive journeys lasting billions of years. They preserve traces of ancient cosmic events long after stars themselves have vanished. In a universe where so much changes and disappears, neutrinos endure. Tiny travelers crossing eternity. Some of the neutrinos reaching Earth tonight began their journeys before multicellular life existed on this planet. Others departed distant galaxies long before humanity evolved. They drifted patiently through expanding space while civilizations rose and vanished beneath them unnoticed. And still they continue onward. Perhaps somewhere far beyond the Milky Way, another civilization is also building underground detectors beneath mountains or ice. Perhaps they too discovered invisible particles slipping silently through matter. Perhaps they also learned that the universe hides deeper realities beneath the visible surface of existence. The laws of physics appear universal, which means the neutrino story unfolding on Earth may also unfold elsewhere among the stars. Invisible particles connecting distant civilizations that will never meet. As our journey tonight slowly approaches silence, it becomes clear that neutrinos are more than scientific curiosities. They are reminders of how incomplete human perception truly is. The world humans experience through sight and touch represents only a thin surface layer of reality. Beneath it lies a vast hidden cosmos filled with particles and forces moving beyond ordinary awareness. And yet, through patience, mathematics, and imagination, humanity learned to hear whispers from the invisible universe. We built observatories beneath mountains. We transformed Antarctic ice into a telescope. We waited decades in darkness for tiny flashes inside pools of purified water, all to catch particles that almost never interact with anything at all. And somehow, against extraordinary odds, we succeeded. The ghost particle revealed itself. Not fully, not completely. Many mysteries remain hidden, but enough to remind humanity that the universe is stranger, quieter, and far more beautiful than human senses alone could ever reveal. Tonight, as Earth turns slowly beneath the stars, neutrinos continue crossing the planet in endless silence, through oceans, through mountains, through sleeping cities wrapped in darkness, through your body itself. Ancient messengers drifting through eternity, and almost none of them will ever stop. Long before humanity understood neutrinos, ancient civilizations looked into the night sky and imagined the universe as something distant and unreachable. The stars appeared fixed beyond human existence, silent lights suspended above the world. But modern physics has slowly dissolved that separation. The cosmos is not far away. It is woven directly into the structure of reality surrounding us every moment. Neutrinos reveal this connection with extraordinary clarity. Right now, while cities sleep beneath the darkness of Earth, particles from ancient stars are moving through every human body on the planet. They pass through forests, oceans, deserts, and clouds without resistance. They cross entire worlds silently. No border can stop them. No wall can contain them. The universe flows continuously through itself. And perhaps nowhere does this become more haunting than inside collapsing stars. When massive stars die, their final moments unfold with terrifying speed. For millions of years, gravity and nuclear fusion remain locked in delicate balance. Outward pressure from fusion pushes against inward collapse. But eventually the stellar furnace weakens. The core grows unstable, and in less than a heartbeat, gravity wins. The collapse begins almost instantly. Matter falls inward faster and faster until atomic structures themselves break apart. Electrons crush into protons. Space inside the core becomes unimaginably dense. A teaspoon of neutron star material formed during such collapses would weigh billions of tons on Earth. The laws of matter strain under pressures almost impossible to imagine. And then the neutrinos come. During those final catastrophic moments, the dying star erupts with an invisible flood so enormous that it briefly outshines the rest of the observable universe in neutrino energy. The explosion humanity sees through telescopes is only the surface echo of something far deeper happening within the collapsing core. The true story escapes through neutrinos, because photons become trapped inside the dense stellar material. Light struggles desperately to escape. It collides endlessly with atoms and plasma imprisoned beneath expanding layers of debris. But neutrinos interact so weakly that even the collapsing star cannot fully contain them. They burst outward almost immediately, carrying information from regions no telescope could ever directly observe. In this way, neutrinos transform exploding stars into cosmic messages. They carry news of death across galaxies. And somewhere in the distant future, another nearby supernova will occur. Perhaps centuries from now, perhaps tomorrow. Somewhere within the Milky Way, a giant star is already approaching its final collapse. When it happens, detectors beneath Earth and Antarctic ice will awaken with sudden bursts of neutrino activity before astronomers even see the explosion itself. Humanity will know a star has died before the light arrives. That idea feels almost mythic. Ancient messengers outrunning visible reality itself. And supernovas are not the only places where neutrinos dominate cosmic events. In the violent aftermath of neutron star collisions, enormous neutrino storms likely shape the formation of heavy elements such as gold, platinum, and uranium. Some of the rare atoms humans treasure most may owe their existence partly to neutrino interactions unfolding during catastrophic stellar collisions. Even precious metals carry traces of ghost particles within their origins. This realization changes how we think about the material world. Objects humans consider stable and ordinary often emerge from cosmic violence almost beyond comprehension. The gold in jewelry, the calcium in bones, the iron in blood, all were forged through astrophysical processes involving nuclear reactions, stellar collapse, and invisible particle interactions spanning billions of years. Human bodies are not separate from cosmic history. They are products of it. And neutrinos may eventually reveal even deeper layers of that history. Some physicists hope future detectors will finally observe the cosmic neutrino background directly. These ancient relic neutrinos have traveled through space since roughly 1 second after the Big Bang. Detecting them would provide humanity with a glimpse into a time far earlier than ordinary light allows. The cosmic microwave background already lets astronomers observe the universe roughly 380,000 years after the Big Bang. Before that era, the young cosmos remained opaque to photons. Light could not travel freely yet, but neutrinos escaped much earlier. If humanity learns to study relic neutrinos properly, we may one day observe conditions from the universe's first moments directly. Imagine that achievement. A species evolving on a small rocky planet around an ordinary star, eventually constructing instruments sensitive enough to detect particles older than galaxies themselves. Humanity reaching backward toward the beginning of time using ghost particles drifting through space since the dawn of existence. There is something profoundly beautiful about this pursuit. Science is often described as cold or detached, but neutrino research reveals another side entirely. Curiosity powerful enough to build observatories beneath mountains. Patience strong enough to wait decades for microscopic signals. Imagination capable of interpreting tiny flashes of light as messages from exploding stars and the birth of the cosmos. The neutrino story is ultimately a story about human persistence against impossibility. For many years, physicists believed neutrinos might never be detected. The particles interacted too weakly. The probabilities were too small. The universe seemed unwilling to reveal them, yet humanity continued searching anyway, and eventually the hidden universe answered. A few faint flashes inside underground detectors. Tiny ripples of blue light beneath Antarctic ice. Small signals buried inside oceans of silence. From those delicate traces, entire new branches of physics and astronomy emerged. The invisible became observable. And now the ghost particle stands among the greatest scientific discoveries of modern civilization. Not because neutrinos themselves are large or powerful, but because they reveal how much reality exists beyond human senses. The universe is deeper than sight, quieter than sound, and stranger than intuition. Tonight, while Earth continues turning beneath the stars, invisible particles older than civilization move silently through the darkness around you. Messengers from the sun, from distant galaxies, from exploding stars, from the birth of time itself. Ghosts crossing eternity without rest. There is a quiet irony hidden within the story of neutrinos. The particles themselves are almost unimaginably small and elusive, yet they force humanity to confront some of the largest questions ever asked. What is matter? Why does the universe exist? How do stars die? What happened during the first second of time? Again and again, the ghost particle leads science toward mysteries far beyond its own tiny scale. And perhaps this is why neutrinos feel strangely philosophical as well as scientific. They remind us that reality is not obligated to resemble human intuition. For most of human history, people trusted the evidence of their senses completely. The earth felt solid beneath our feet. The sky appeared to circle above us. Matter seemed dense and permanent. Empty space appeared truly empty. But modern physics has steadily dismantled these assumptions one by one. Atoms turned out to be mostly emptiness. Time became flexible under gravity and velocity. Space itself bends and stretches. Particles behave like probabilities instead of miniature objects. And now neutrinos reveal that the universe is filled with invisible rivers of ancient particles moving through everything almost without resistance. The deeper humanity investigates existence, the stranger existence becomes. And yet there is beauty in that strangeness. Neutrinos teach us that invisibility does not mean insignificance. These particles rarely interact with matter, but their influence stretches across cosmology, stellar evolution, and the origins of galaxies themselves. They participate quietly in processes shaping the entire universe. In the hearts of stars, neutrinos carry away energy and regulate stellar collapse. During supernovas, they help drive explosions powerful enough to forge heavy elements later scattered across space. In the early universe, they influenced the growth of cosmic structure itself. Even though they almost never touch ordinary matter directly, their presence subtly helped shape the cosmos humans eventually inherited. The invisible still changes reality. This idea extends beyond physics. Human beings naturally focus on what feels immediate and visible. Bright stars, explosive events, tangible objects. But much of existence unfolds quietly beneath the surface. Invisible magnetic fields guide galaxies. Dark matter shapes enormous cosmic structures while remaining unseen. And neutrinos drift through eternity carrying hidden information from places light cannot reveal. The universe is filled with silent forces. Perhaps this is why neutrino observatories possess such unusual emotional atmosphere. Scientists working inside these underground detectors often describe environments of profound stillness. Deep beneath mountains or ice sheets, ordinary human noise fades away. There are no city lights, no weather, no movement except the slow operation of instruments waiting patiently in darkness. It almost resembles meditation. Humanity sitting silently beneath the earth listening for whispers from the cosmos. And the whispers arrive rarely, sometimes only a few interactions per day. Tiny flashes inside immense chambers of purified water. Brief traces captured by sensors frozen beneath Antarctic ice. The signals are fragile and difficult to interpret. Yet hidden inside them are stories from exploding stars, violent black holes, and perhaps the earliest moments of time itself. There is something deeply humbling about extracting cosmic truths from such faint evidence. It reminds us how small humanity remains compared to the scale of the universe. The cosmos does not easily reveal its secrets. It whispers them slowly across billions of years through particles almost impossible to catch. Every discovery requires patience, cooperation, and generations of accumulated knowledge. And still the universe retains most of its mysteries. Even now, physicists suspect the known particles and forces describe only a fraction of reality. Dark matter remains unidentified. Dark energy driving cosmic expansion remains deeply mysterious. Quantum gravity continues unresolved. And neutrinos themselves still behave in ways no theory completely explains. The ghost particle stands like a doorway between known physics and unknown territory. Some scientists even wonder whether neutrinos might connect to hidden dimensions or undiscovered cosmic fields. Others suspect they may reveal entirely new principles governing the universe beyond the standard model. History suggests caution because neutrinos have already surprised humanity repeatedly. First, they appeared as invisible solutions to broken equations. Then they were detected experimentally despite seeming impossible to catch. Later, they revealed unexpected mass and oscillations that overturned assumptions inside particle physics itself. Again and again, neutrinos force science to expand, which means the next great neutrino discovery may once again change humanity's understanding of reality in ways impossible to predict. And somewhere beyond all the equations and detectors lies a quieter emotional truth. Neutrinos reveal that human existence is woven deeply into cosmic history. The same laws shaping distant galaxies also shape atoms within your body. The same particles born inside stars now move silently through your heartbeat. There is continuity between the universe and yourself far more intimate than ancient civilizations ever imagined. You are not merely observing the cosmos. You are physically immersed inside it. At this very moment, while you rest beneath the night sky, neutrinos from the sun are passing through your skin by the trillions. Some continue downward through the entire Earth before emerging into space again. Others arriving now began their journeys in distant galaxies long before human civilization existed. Ancient particles from the early universe itself drift through your body without pause. The cosmos is flowing through you continuously, and yet you remain unaware because human senses evolved for survival, not cosmic truth. Eyes detect only a narrow band of light. Ears hear only limited vibrations. Touch perceives only electromagnetic resistance between atoms. Most of reality unfolds outside ordinary awareness. Science became humanity's way of extending perception beyond biology. Telescopes expanded sight across galaxies. Microscopes revealed hidden cellular worlds. And neutrino detectors allowed humanity to sense particles nature never intended humans to notice directly. That achievement feels almost miraculous. A species emerging on a small planet around an ordinary star, gradually learning how to detect ghost particles crossing the universe since the beginning of time. Perhaps that is the deepest lesson hidden inside the neutrino story. Reality contains far more wonder than human senses alone could ever reveal. And the universe is still whispering. As humanity continues listening to the universe through neutrinos, an unusual realization slowly emerges. The cosmos is not only stranger than ancient civilizations imagined. It may also be stranger than the human mind is naturally equipped to fully comprehend. Again and again, neutrinos force science toward concepts that feel almost dreamlike. Particles changing identity while traveling. Matter behaving like waves of probability. Ancient messengers crossing billions of years without touching anything at all. And yet every experiment keeps confirming the same impossible truths. This tension between intuition and reality sits at the center of modern physics. Human brains evolved to survive on the African savanna, not to visualize quantum fields or the interiors of collapsing stars. Our senses interpret only the narrow slice of reality useful for survival. We see visible light because it helps us navigate. We feel solid surfaces because electromagnetic forces prevent us from walking through trees or cliffs. But nature itself operates far beyond those biological limitations. Neutrinos belong to that deeper hidden layer. And perhaps that is why they feel almost mystical despite being completely physical particles governed by precise mathematical laws. They exist at the boundary where ordinary experience fails. Invisible yet real. Nearly massless yet cosmically important. Silent yet carrying messages from exploding stars and the birth of time itself. Even the way scientists detect neutrinos carries a certain poetic quality. Most observatories do not actively hunt particles in the traditional sense. They wait, quietly, patiently, sometimes for years. Huge underground detectors remain submerged in darkness listening for tiny flashes that may appear only rarely. Human beings creating instruments sensitive enough to notice almost nothing. There is humility in that approach. The universe does not surrender its deepest truths through force. It reveals them slowly to those willing to listen carefully enough. And the more humanity listens, the more interconnected everything appears. Consider the strange journey of a single solar neutrino. It begins inside the sun's core where hydrogen nuclei fuse together under pressures and temperatures beyond imagination. The neutrino escapes almost immediately because the star cannot meaningfully contain it. 8 minutes later, after crossing 150 million kilometers of space, it reaches Earth, passes through clouds and atmosphere effortlessly, through buildings, through stone, through your body itself. Then it continues downward through oceans, magma, metallic core, and the entire planet before emerging silently into space again. A particle born inside a star briefly crossed your existence tonight without either of you noticing. That image quietly dissolves the illusion of isolation. Human beings often imagine themselves separate from the wider universe. But neutrinos reveal continuity instead. The sun is not merely shining upon Earth from a distance. Its particles are physically passing through every living creature constantly. The boundary between cosmic events and human life becomes strangely thin. And the same is true for distant galaxies. Some neutrinos now moving through your body began their journeys near violent black holes billions of light-years away. Others emerged from ancient supernovas before Earth existed. A few relic neutrinos surrounding the planet may have traveled uninterrupted since the first second after the Big Bang itself. You are immersed inside ancient cosmic history every moment. There is also something haunting about neutrino longevity. Many particles decay rapidly into other forms. Even stars eventually die. Galaxies collide and transform across cosmic time. But neutrinos endure. They cross unimaginable distances almost untouched. Tiny travelers surviving journeys spanning billions of years. In a universe filled with destruction and transformation, neutrinos become symbols of persistence. And perhaps this endurance explains why physicists continue believing they may unlock even deeper truths still hidden from science. Some future discovery involving neutrinos may reshape cosmology once again. New flavors, unknown interactions, connections to dark matter or quantum gravity. The history of neutrino research repeatedly demonstrates that whenever humanity believes it understands the ghost particle fully, another mystery emerges from the darkness. The universe keeps widening. This endless expansion of knowledge can feel unsettling at times because certainty becomes increasingly fragile. Each generation of science discovers that previous assumptions were incomplete. Reality keeps revealing deeper structures beneath familiar appearances. Yet there is also comfort hidden inside this process. The cosmos remains alive with mystery. Existence has not become smaller under scientific understanding. It has become larger. Neutrinos embody that enlargement beautifully. A century ago, humanity did not know these particles existed. Today, we build detectors beneath mountains and ice sheets to study their behavior. We use them to observe stellar collapse and investigate the origins of matter itself. We track particles crossing galaxies and arriving beneath Antarctic ice after journeys lasting billions of years. Human awareness has expanded into realms once completely unimaginable. And still the neutrinos continue flowing silently around us. At this moment, Earth is moving through a vast ocean of invisible particles. Solar neutrinos stream outward in every direction from the sun. Atmospheric neutrinos rain downward from cosmic ray collisions above the planet. Relic neutrinos from the Big Bang drift quietly through intergalactic space. Ghost messengers from ancient supernovas cross the Milky Way in silence. The universe is alive with invisible motion. Yet human civilization proceeds mostly unaware. Cities glow beneath artificial lights. Oceans rise and fall beneath the moon. People sleep, dream, worry, hope, and grow old while countless neutrinos pass unnoticed through their bodies every second. Ancient particles from the birth of time itself crossing human lives silently without leaving a trace. There is something strangely peaceful in that image. The cosmos does not stand apart watching from a distance. It moves through us continuously. The universe is not only above us in the stars. It is here, flowing invisibly through every heartbeat and every breath. And perhaps that realization softens the loneliness people sometimes feel beneath the night sky. Because even in silence, you are never separate from the cosmos. The ancient universe is touching you constantly through ghost particles drifting across eternity. And it has been doing so since the beginning of time. And now, as our journey slowly drifts towards silence, the neutrino story leaves us with one final realization. The universe is not built only from what can be seen. Beneath the visible surface of reality exists a hidden cosmos filled with ancient particles, invisible forces, and quiet processes unfolding continuously around us. Human senses reveal only a thin layer of existence. Yet through patience and curiosity, humanity learned how to listen beyond those limits. The ghost particle became proof that reality extends far deeper than appearance. For thousands of years, people looked at the night sky and saw distant points of light, beautiful but unreachable. Modern science transformed that image completely. Stars are now understood as nuclear furnaces. Galaxies drift through expanding space. Black holes warp the fabric of time itself. And neutrinos stream invisibly between all these structures in endless motion. The cosmos is no longer distant scenery. It is alive around us. At this very moment, while the Earth turns quietly beneath the darkness, trillions of neutrinos are passing through your body every second. Some were born only minutes ago inside the sun. Others began traveling before humanity existed. Some emerged from exploding stars in distant galaxies. A few may have crossed the universe uninterrupted since the first second after the Big Bang itself. Ancient messengers are moving through you now, and almost none will ever stop. There is something strangely calming about that thought. Human life often feels fragile and temporary. Civilizations rise and disappear. Oceans shift. Mountains erode. Stars themselves eventually collapse and fade. Yet neutrinos continue their silent journeys almost untouched by time or matter. Tiny travelers crossing eternity through expanding space. Perhaps that endurance offers a different way to think about existence. The universe is not static. It is movement, continuous motion flowing across scales far beyond ordinary awareness. Galaxies rotate, space expands, particles oscillate between identities. Invisible rivers of neutrinos drift endlessly through worlds and stars. Reality itself resembles an enormous unfolding process rather than a collection of permanent objects. And somehow, for a brief moment, human consciousness emerged inside that process. A species born on a small rocky planet learned how to detect ghost particles from exploding stars. Learned how to study relics from the birth of the cosmos itself. Learned how to build observatories beneath mountains and ice in order to hear whispers from the invisible universe. That achievement feels quietly extraordinary, not because humanity conquered nature, but because humanity learned to listen carefully enough to notice realities once thought impossible to observe. The neutrino story also reminds us that mystery is not failure. Modern science often celebrates certainty, equations, and precise measurements. Yet some of the greatest discoveries emerged because physicists allowed themselves to follow anomalies and unanswered questions. Missing energy inside radioactive decay led to the prediction of neutrinos. Missing solar neutrinos revealed oscillations and hidden mass. Tiny discrepancies open doorways into entirely new physics. The unknown became a guide, and there are still countless mysteries waiting ahead. Scientists continue searching for the exact masses of neutrinos. They still do not know whether neutrinos are their own antiparticles. They continue investigating whether hidden sterile neutrinos exist beyond the known 3 flavors. Future discoveries may reshape cosmology once again. The ghost particle still carries secrets hidden inside its silence, which means the universe remains unfinished in human understanding. There will always be deeper layers beneath the visible surface of knowledge. New questions emerging from every answer. New hidden structures waiting beyond the edge of perception. And perhaps that endless unfolding is part of what makes the cosmos so beautiful. Because a fully explained universe might feel strangely empty. But this universe still whispers. Tonight, somewhere deep beneath Antarctic ice, detectors continue waiting in darkness for flashes from distant galaxies. Beneath mountains, pools of purified water remain perfectly still while invisible particles cross them silently. Somewhere in the cosmos, giant stars are approaching collapse, preparing future neutrino storms that may one day wash across Earth before their light arrives. And above all of it, the universe continues expanding quietly into the unknown. As you rest now beneath the night sky, imagine the invisible ocean surrounding the planet. Rivers of neutrinos crossing oceans and continents without resistance. Ancient particles from dead stars passing through sleeping cities. Relic messengers from the beginning of time drifting silently through your heartbeat. The cosmos is not far away. It has always been here, flowing endlessly through every atom, every moment, every breath. And perhaps the deepest lesson neutrinos offer is not merely scientific, but emotional. Reality is larger, stranger, and more interconnected than human beings naturally perceive. We are woven into cosmic history far more intimately than ancient civilizations ever imagined. The atoms inside us came from stars. The particles around us carry messages from the birth of the universe. The boundary between ourselves and the cosmos is far thinner than it appears. You are not standing beneath the universe. You are inside it completely. And while the night grows quieter around you, the ghost particles continue their endless journey through darkness, through stars, through galaxies, through Earth itself. Ancient travelers crossing eternity in silence long after human voices fade away. The universe whispers continuously. And tonight, for a little while, we listened.